Okay. Um, First of all, just in case you've missed it beforehand, Jeff Goff from Evazon in Romania. We're talking here about, we're going to start out with a basic introduction to Perl6 real expressions, and at the end, we will be able to do a portion of a just-in-time compiler for JavaScript, a very small portion. Yeah, just 1 or 2 lines. This technique, I'm going to show off a technique that I found that's useful for trying to deal with, say, instead of having a explicit grammar handed to you for how to parse a document, we'll take it apart string by string and step by step. So things will be very basic at the start. I'll cover some other basic constructs. Don't expect to see too much in the way of the fancier Perl OO operations and hyperoperators and whatnot. I will cover some OO at the end, and we will learn a way to take JavaScript and factor down to a more proper object tree. But we'll start out with something as simple, and I'm supposed to do that for sync purposes. And we'll start out with the basic ISO 8660, I believe that's the number, date format. For those of you that do Perl 5 these days, or even Perl6 will recognize this, hopefully. Say, just prints your output to the screen, and here is a standard ISO 8601, date format string with year, month, and day in the proper order for those listening in Europe. Key for marking the time zone, and then the actual time followed by the time zone offset, or Z, or Z properly speaking, for those of you in the rest of the world, for Zulu. Again, a pretty straightforward format. Hopefully common, you see this in Apache log files, you see this in a lot of applications. Like so. And of course, you may have if you're in Perl 5 or Perl 6, you'll know that this is how you perform a match. These characters have not changed since Perl 5. The starting and end markers, you can still do things the way you used to, almost. The tilde is now how to properly execute a match. And this will return a match object, except for the syntax error buried down here, the dashes and the colon. Because as opposed to Perl 5, where you had to go through, basically figure out by combinations of backslashes and $signs and escape symbols and double backslashes, now all you need to know in Perl 6 is that if it's a number or a letter or something that Unicode calls a letter, then it's fine. Anything else, like the dashes here, or the plus sign, or the colon, those need to be escaped. You can do that in 2 ways, which we'll go into in just a moment. The first thing, though, and is sort of gauche to point out a syntax error in a slide, but in this case, I think it's worth pointing out for those of you that have not been deeply yet into Perl 6, how useful errors are now. In Perl 5, if you have a match failure, you'll get a single line comment detailing unescaped character about line this in your file, 1 line buried somewhere in the available log file. In Perl 6 now, that has expanded, so you get, first of all, a large warning marker saying something has happened with the star right up here, and then several details as to what actually happened. Detail of the file, the expression, and missing slashes, and this right here, which I just spoke about, the unrecognized meta character. So it's telling you exactly what happened, exactly where in the file, and right down to the actual character. The eject symbol here indicates where the parser notionally ejects. It goes through the slash and finds 2016, and then the dash is a meta character that it can't deal with. So the parser metaphorically, I would make a joke about that, but I won't. Yeah. The parser metaphorically ejects at that character and says, right here is where you need to work. So you have exact marker as to where the problem started and an indication as to what you need to fix. Must be quoted. So we shall do so on the next slide. In this case, we shall use the backslash method to quote the string. You can actually use double quotes as well, and that's kind of how I prefer to do that. It makes a more visual marker to find out where you are in a string. It calls out something rather than having a long string of backslashes, etc. I prefer the quoting method myself, but I'll be using a mixture of things. Now, for those of you that were in the OO tutorial a little while ago, and we've been hammering the message home as well, you may know that everything now in Perl6 is an object. And these markers down here, the Japanese angle brackets, tell you that you're looking at an object. It is very handy for debugging. For those of you that are used to Perl5, if you have, say, if you try to debug a hash or debug a hash reference, you'll see this hash parent 0x1235, which helps no one in your debugging statement. In Perl6, you get the actual text back along with whatever detail it has on that. In this case, it's a simple match, and it returns what you matched, as opposed to contents or a hash ref or a array ref that you have to try to go back and use data dumper or use YAML and print that out. Much handier when you're there on the command line doing your work, trying to debug things. You can also use new lines here to break out the expression. That is now default. It's effectively the same thing as /x in your expressions. So you I'm choosing to break up the date portion, time, and time zone separately, as you would if you were trying to parse this yourself. You would probably want to know what the date is, be able to print out just the date, be able to print out just the time, and we'll throw in a space here at the end to break that out, or just check out the time zone offset. And the object has not changed from this. These examples all by the way, run on your local Recruiter for those of you who want laptops and typing away furiously. Just like in Perl5, comments work as well with the /x modifier. As I said, that's now standard. So you can document your date, but you can go even one better. You can go in and capture text. And this time, we have a change. What before was a simple, straightforward, single match object, now we have the original match object and all of these sub-matches displayed right there. You don't have to go through and, in your work expression, go through and try to print out $0, pardon me, $1, $2, $3, $5. You don't have to go through all that nonsense. Instead, you simply print out the actual object. And you have all the detail right there. Index 0. And by the way, 0 is now where we start. It used to be $1. Yeah. And now we reserved $0, or taken away, I should say, $0, into your program name, and now all the 0th match starts at $0 and index 0 in the match array. So we take all this content here and put it into our separate matching. This should all be pretty familiar to you as well from Perl5, because this is the equivalent roughly of $1, equivalent of $2, $3 down there. So this has analogs directly in Perl5. Although you wouldn't get an object back, you would have to do some parsing and reinterpretation to get that back as an object. So $0, as we said before, this content right here is the date. I did it originally at FOSDEM, and that was the starting date for FOSDEM. Moving onwards, some of you may have actually used the name capture feature in Perl 5. This is kind of the same thing. This is not in general how we do things in more modern Perl 5. I'm trying to explain this as a way to migrate into more common concepts, or at least more Perl 6-ish concepts. But if you still want to use standard name captures, you can do it like this in Perl 6. You have $, and then the pointing bracket here for the date, and assign to the match. So you get back this time from your match object. There is a missing line up here, deliberately. You can get back a hash now of your contents. So instead of beforehand, over here we have an array of matches because they're not named. Perl 6 is smart enough to know that we want named hashes. So we have names such as date, time, and time zone. But we're not quite clean enough. So let's take the T marker outside there and get rid of that. So now the time appears 1325 as opposed to T 1325. Clean up just a little bit. Time zone, we'll deal with that later on when we actually specify how to. Oh, we have a question back already.
So when you do this, is $date now a variable, or is date the key of a hash?
Okay, $brace date here is syntax inside Perl 6. What you get out of this, I will show you in just the next slide how to access the content down here. Now, you may remember, now you see these markers up here and here, the slash signs? Those are a mnemonic to remind you that the match object, in fact, starts with a slash. I don't have that slide just yet, but I will show you in more detail how to get to that data. Suffice for now to say that the slash, that is all in $slash, one of few punctuation variables in Perl 6. Those have been cut down drastically, especially the fun ones like, say, a dollar close bracket, dollar open bracket. That will throw you in Perl 5 rail expressions if you've ever tried to match open bracket 0 through 9, $sign, close bracket, because you keep forgetting that $sign, close bracket is a variable. That has all gone away. Now, the big thing here, compared to, say, this, we have the $brace date notation here assigned to the capture. What we're going to do is take that and move that outside the expression, because we're all good programmers and we want to refactor where possible. And we are repeating this construct here. $brace foo equal that, $brace time equal that, $brace time zone equal that. We want to refactor that pattern out. So we want to we'll capture our date in a separate rail expression out here, our time in our expression, and time zone in another expression, and use that inside here. So now we have a way to capture our date that we put into any script that we want. We take that and move it into, say, a library, or move it into a separate .pm file, and load that later on. And we capture the date the same way, the time in that fashion. And here the time is without the T, so the time could be any string time. It's no longer tied to an ISO timestamp. And we have the time zone down here as well. And again, I'll get very quickly on to how to actually use this in your actual code. Going a little bit, okay, we have.
Sorry if I'm rushing again, but
no problem, no problem.
Why curly braces for the regex instead of slashes?
Yeah. Okay. That is because these are now blocks. Basically, everything now in Perl 6 that is in curly brackets is a block. This includes, unfortunately for those of you that are trying to migrate from Perl 5 to Perl 6, this includes brace bear word name for keys. And that tripped me up for several days, trying to go through and remember, oh yes, I'm in Perl 6 now, that doesn't work. I need to use the angle bracket syntax down here. That tripped me up for a few days, but I got used to it.
They really are methods inside, and so outside they use the same block notation as method works out uses. It just switches to a different language inside of that.
Right, so what is
Right.
it that triggers it to interpret the inside as a regex as opposed to code?
The declarative regex.
Okay.
Yeah, the marker over here. In the same way you would have class date or grammar date, but I'm getting ahead of myself. Like so. No worries. It's all good. So now what we used to capture is down here in a comment. We move this out into a separate date and move this out into our own time regex. So we can use that and move it around. So let's take a few minutes to clean that up, get rid of the comments. And now the big thing here, of course, is trying to match just a static string like this with a static hardcode number for a year and month and day isn't going to help that much, because in the real world, well, days change, times change. So we want to be able to match. So when we go from January to February, we want to be able to change from 01 to 02. And if we say move from the US to Romania, we want to change the time zone from -2 to all the way around -7 to +2, which will be a really fun flight on the way back. So we'll use the same notation that you're used to in Perl 5 with /D plus. I will qualify that this is not going to quite match the same real expression, as this is a four-digit number, this is a two-digit number, and okay, excellent. So I want to turn on the power script. Yeah, this will match, say, a 4 or 5 digit year. So for those of you at the Low and Now Foundation, you'll be glad to know that you can use 02000 for the year here. Yeah. But in this case, it'll be a little bit larger for slide in order to put all of the day qualifiers in there. You would use \D **5, or **4, **2, etc. for matching the exact number of days, but that would stretch things out just a little bit on the slide. So for the moment, I'm going to leave that aside. So moving onwards, you may remember from Perl 5 how to do alternative expressions. So we have the plus time zone or Zulu. So now we can match either a plus offset or Zulu. You can imagine how you would match a negative offset up here. Say +/D plus :/D plus, or yeah.
What does the Zulu signify? GMT?
Technically, yes. I'm sure if Zephyr were here, he would qualify. I think that Zulu is actually UT2. Yes, there are different variants of time zones, but Zulu is a Greenwich Mean Time, effectively.
I'm just going to look up 8601 and read about it.
Feel free.
And then there's Mars.
Yeah, exactly.
An offset every day is real hard.
Yeah. Yeah, and souls. And the rover must get confused when talks home. Okay, so moving on from there, and this is what you're after beforehand in the back. The Dalton, again, this is mnemonic because you're performing a match. the slash here turns into a dollar slash. So you perform the match here, and you can look up the contents of your date as the dollar slash brace date. So, pardon?
It's like a hash.
Yep.
What uses the dollar.
Slipping too much. Okay. All right, so now that we have our expression here, let's take this out and refactor that into another regular expression, because we can compose expressions inside expressions. This is also just a block of code. So we put our break state inside here, and this date refers to that date. So now we've created a little bit more complex data structure, but you'll notice that this is all nested. You get this for free. If you were dealing with Perl5, you would have to go through and count your opening and closing brackets. I certainly hope I'm not going to run out of power. Or maybe the. Yeah. Anywho, you have the main expression here. Now here was the full ISO 601 timestamp that it matched. All the text that matched there, ready, available for you for debugging. When you can't figure out why a offset is wrong, Perl tells you exactly what's going on, what's matching. And inside the ISO timestamp, inside that key, you have down here another date key, another time key, and time zone key, all nested within the data structure.
Would it do something useful to you if date was somehow repeated? I mean, obviously in this case that would make no sense, but in many cases, you know what I'm saying? Like you have the same that date, you know, it's.
I think you have to refer to it as $/ISO 8061.
Correct. All right. The question for those of you that can't hear was, how will you refer, if I'm interpreting correctly, how will you refer to the nested expressions inside here?
Well, my question is, let's say for example that for the heck of it, you changed all those backslash p pluses to my regex backslash p plus, or you actually gave it a name. Okay?
Right.
Now you have that name in 1, 2, 3, 4, 5, 6, 7 places in the regex. You would actually list those would get listed individually in your set.
The question is, if you were to interpret, if you're to add, and we do this by the way later on. Thank you for, thanks in advance. How if we were to say create an int type to unsigned int, if you will, to interpret the /d plus here and populate that as regex, how would that work? You would certainly be able to insert the int marker here, the int there, and that would all come out as an array. An array inside the int type. But there's a way to work around that if you need to disambiguate things, and we'll actually get into that here fairly shortly. Let's see here. All right, and again, this is a full object, just to keep in mind where we are. The original match, the ISO format here, and inside there is the date. So you'll be able to represent that by, let's go back here, for example. Insert the ISO 8601 right here between that, and reference the hash key in that fashion. Okay, now we're going to kick it up a little bit. We want a little bit faster. So just to clarify and cement in mind where things are. Obviously, instructions, obviously REs are meant to match text. This was originally a beginner talk for FOSDEM for a wider version, a wider contention. The tilde here over here is how you do the matching. Capturing is still works the same way with parent through close parent. You can name your captures, or do at least what I consider the right thing, and refactor using my regex and separate out your regexes. Say you're dealing with the infamous email regex, which it covers 30 some pages and is largely unreadable even with the /x. This way you can take that and refactor each of the regexes out into their own bits and reuse those bits inside a straight Perl6 Perl expression. We'll talk about tokens here in a few moments when we switch from dealing with a basic Rails expression like you would use for, say, a log file to a more complex expression. Like, just to be ambitious, let's tackle JavaScript as a language most of you should already know. Now, this is a little bit different than how a lot of people would approach this. We're going to assume here that there is no grammar extant for JavaScript, so that you don't have a way easily to go through and create your own BNF grammar for JavaScript. We'll assume we're doing this from a blank slate. So first thing we want to do is take an expression like, say, console.log sum is, and then +32, and try to form a way to match that and parse out the important bits right here, the sum, the 32, and the console.log, to be able to, say, reinterpret that in Perl. So we'll start off with the base expression, say this, and then matches our JavaScript token over here. The name token is slightly different than regex. Is the same thing essentially. The white space rules differ a little bit, but the important thing is to know that it's a regex. That's right here matching a single constant string. And what we want to do there is go through the string and break down the contents, like we were doing a few minutes ago. This time, though, we'll do this with grammars and end up with a way to compile, essentially, if you do a little bit more work, all of JavaScript in the same way. So we start out with our expression here, and we want to be able to obviously deal with the sum +32 separately. That way we know what the content is, and be able to match any string we want. So we'll take our JS and drop in the token string here, which you've seen previously, and create quotes, .star requests, quotes. Again, you've seen this in Perl5, I'm sure. They use the non-greedy quotes right there, modifier, that still works. It's a little bit different semantically now in Perl6, but not that much different. So we have our JS matcher, captures console.log, and then any string we want, followed by the expression +32, close parent. And now here we have our full JS expression, and inside that we have our string. So we have a way now to break this down and break the string down bit by bit. And if we have a problem, we can always go back to the previous version, find out why that match didn't work, go forward, do a git reset, and go ahead. So we have this way, essentially a way to go through the string monotonically and parse out each bit that we want and put it in the right places, like so. Get a little bit more detail down here, and at the and for 32 now we use the \d+, which again you're all familiar with, and this also speaks to what we were talking about in the back there, how to handle int. So now we have the string. We have console.log string plus int, which for those of you that are more familiar with, say, compilers or parsing, you'll start to recognize it's a little bit more, because you have the JavaScript matcher here, and this side here you have a separate matcher that you pull out for your strings, a separate matcher for your ints that you can repeat anywhere in your grammar. Oops, got a little ahead of myself there. And down here, of course, we have JS, and inside there is our string with the quotes here, which we don't really need. And obviously down here, the int. And again, JavaScript is telling us that these are objects, as everything in Perl is now. So one thing before we can go and tackle the entire statement here is to get rid of the quotes. So we will do that in 1 second. And this also speaks to what we were talking about beforehand, how to get nested matches out. We have our JS down here, and inside that we have the string match over here. So we have the JS, and inside that you have the string. And what we have here, you'll notice with a little bug right here and here, you'll notice that we have essentially rewritten our JavaScript in Perl. Because say JS string tilde JS int, and the tilde here, by the way, is concatenation. The dot now is being reused for other things. We have essentially recreated the original JavaScript statement in Perl. So if you want to start on, say, your own JavaScript interpreter in Perl, this would not be a bad base to start from. Because you can, of course, choose different ways to match console.log parent, close parent, etc. Choose different ways to match your string plus int, or int plus int, or string plus string, or string minus string, or whatever the JavaScript allows you to do. You find ways to build up on that. So we'll get rid of the quotes here. And again, this may not be the most elegant way to do things, but if you're going step by step, I find it's better to go to take one string and just modify one expression at a time to keep things in your mind, keep them fresh. So we're just modifying one bit down here. We're going to capture just the interior inside the quotes with our old friend. We all remember these from Perl 5. I think we have. Okay, well, should I move on or? Okay.
What was the difference between a rule and a token?
Okay, I think that, yeah, okay. The only important rule for us to know right now is that the rule is more lenient on white space. Specifically, if I took the string and removed that white space there and that white space there, it would still match. Whereas if I took the, if I added white space to the string up here, this would, if I have white space in this match, it would appear in the string content here. That's white space on either side.
Would it be fair to say that white space either before or after a token is ignored?
The rule is actually, between two identifier characters, if I remember rightly. Right. Right. And again, we're going to go a little deeper inside here and look at that match. So this is how you would go from, say, a named capture to a numbered capture. The string here is the name, and the number down here is number 0. So that's how you do nested captures. There are other ways to handle this, and I will get into that at the very end. And I'm sure we'll either have a lot of questions or I will see heads popping. Well, we'll get into that very shortly. I'll make one slight change here and use the new character class notation here. Basically, it says anything that is not quotes between the parents. If you're familiar with regular expressions, you're probably familiar with the proper. This is not quite the proper way to handle this. This does not handle in any way escape expressions or escape strings with quotes foo, / quotes foo. This will not handle that. That is more advanced and beyond the subject of the talk. But this is now how you do the character class. So we have the character class here. Again, open bracket, close bracket, open bracket, close bracket. It's just that inside here is the old square bracket that we're used to. So you take your roll expression, and if you have a negation like a caret at the start, move that outside, change it with dash, and just leave the rest of the content aside. Question? Okay. All right, cover that. And when we do the file save statement, in roughly, say, 4 lines of code, we have a miniature JavaScript interpreter. It takes a console.log statement and turns it from JavaScript into Perl. Console.log is roughly, yes?
The string looks like it can't be an empty string.
The string there, or,
No, the definition.
oh, yes.
For starters.
Yes, it should be, yes, it should be star. Yeah. Only 1 bug so far, that's good. There's a file stem and ran into a few issues. Okay. Well, quite correct. What Merlin was pointing out is that the string here cannot be empty because of the plus sign here. And quite correct. But again, in 1, 2, 3, 4, 5 lines, you have a JavaScript interpreter in Perl. Admittedly, very limited. But this is a basis where you can take this and put in different rules, change your names, change expressions, put those in, add those alternatives, and as you go through your JavaScript code, learn what those are, add those, substitute those in, and work with that. Now, beforehand, we had all these tokens here. There's tokens and rules going on. It'd be nice if we could actually wrap those up into a neat little package, like a class. But tokens and rules, those really aren't what you think of as a method or a subroutine. So they really don't belong in a class per se. In Perl6, they belong in a grammar. For those of you that sat through, those of you that were here for the previous OO tutorial, you'll recognize the roughly same notation: grammar and then name, open brace, close brace. Compared to, say, class, JS, open brace, close brace, is the same thing, but grammar provides a little bit different syntax and a little bit different sugar, so that the tokens here work in place of a method or in place of a subroutine. So those are all now neatly packaged. So this is now a class file that you can move around. You can create your own js.pm, put it up onto modules.perl6.org, and everyone else will be able to use your grammar as it is, as a tiny JavaScript parser. So this entire file here is now this entire file here, entire brace from brace to brace is one file. There is one change here, and that is because we start out here with we start out here with the rule JS and matching on JS. Grammars have an easy way to tell you where to start parsing. And like most things in Perl, if you are being shouted at, this is an important thing for Perl to know about. And in this case, it's important for Perl to know where the top of the grammar is, the first declaration, the first thing that we get parsed. Right. Yeah, we're coming up to that actually. Yeah. So we replaced JS now with top. So whenever you use this grammar here to parse anything, like so, it will use this rule here as the start. And because now we are in a more packaged state, in a more controlled environment here, just like grammar and like class and like role, you can do the same thing you can with the class. You can call new on the class.
You don't actually do that.
Right.
Parse basically is a construction.
Yes. Yeah, let us point out that the new here is redundant. So you can actually say js.new.parse or use js.parse directly. That's another one of the syntactical sugar that gets provided for you. So, from where we are right here, we have this expression, and we're parsing our text and saying the output. But it'd be nice if we had a little bit more information there, or at least being able to package this up a little bit more neatly. Because right here we have a grammar that does the stuff, and we're doing parsing, and we have this say thing down here that takes the content from the grammar. And by the way, this populates directly into $/ in case you're wondering where the say went, where the say / went. The js.parse puts everything into an implicit match object for you. Again, make things much easier. Handland 245. All right. So from there, beforehand we had this little bit down here that was saying the string. It'd be nice if we can move that as well into a class, because what we have down here, the string and int, that ties directly into the class content, the grammar content here. So it'd be nice if we had a one-to-one relationship between, say, the top rule here and what we're doing with the code down here. Well, thankfully, we have just that. Here is a new class which consists of all of the things that the grammar can do. So whenever you match a rule down here, the rule top, Perl6 automatically runs our method for us. And we tell it to do that by adding this little bit down here. And I've taken some liberties with using the new notation here for a pair. Colon actions. This could easily be done as well with what you're more familiar with, actions, fact comma, JS actions.new. That will work out just as well. I chose to throw in a little bit more of the more Perl6-ish syntax. An example. But we now have a grammar file here, a JS grammar, and a action file, JS actions, that you can take and package that up, and again put that up onto modules.perl6.org. And anyone now that wants to be able to parse the JavaScript string and do something with it can use this without having to do any separate work. We packaged up all of our activity up here, handling the top rule. So when you go through console.log, sum is and the rule top finally completes, it will call the action right down here. So from this down to here, we have JS and this action down here for this output. Now we can get rid of some more lines, and we have one step, JS dot, ignore the dot new, JS dot parse, and then run the actions and get response back. Which again is now a 1, 2, 3, 4, 5, 6, 7, 8. 8-line JavaScript interpreter, admittedly very small. Micro.js, if you will. Actually, nano these days, especially with React.js. So you have now a 8-line interpreter for JavaScript. Of course, you have to do a little bit more work to fill this out. I leave that to the student, as I say. But we can go a little bit further here as well, because you have this say here. It's not really useful for a class to just say stuff. We want to be able to return stuff. Like we want to be able to find out what this console.log entry is in here. We want to be able to find out a little bit more about what's going on inside that. And I think that I ran through the wrong set of slides here. Yes, I did. I have one I need to change here. One moment. Ah. I knew that would trip me up. Okay, let me get back to this point. Allow me to introduce one more rule here, the method name for console.log. So now, now our top rule here with this introduction here looks very much like an output from your typical Yak or Bison or Antler parser. Or if you're familiar with BNF, it looks very similar to a simple BNF notation. You have down here a method name, like you would for console.log, and here method name is console/w plus dot, and then log over here. So this now looks very much like the output from say Antler or Yak or Bison, the source file that you get. And finally, this I ran across a couple of days ago when working on some other slides. What we'll do is introduce one more class over here called a method call. That's going to encapsulate all these details. So, like any language, well, most languages I should say, your method calls have a name and a list of arguments. This will be familiar if you've been through the OO class. And what we'll do at the very end, the top method will create a new method call using the method name from the top and using the arguments inside that, create an argument list. So we have our method name being console.log and our first argument here being this string right here. So now your method call is an object that you can look at, which has a name method, or it has a name and a list of arguments. And finally, if we add a method called Perl6 on that, then down here at the very end, you get essentially what we've been working with all along. You get say, with this little change up here, you have down here, you pass in this string here, and you get back, thank you, you get back, say, sum is tilde32. With again these additions. And I didn't have a real chance to cover what the make here does. The make returns, instead of a string, returns an AST object, which is an abstract syntax tree, which is what Damien was talking about during his keynote. This is the actual mechanism down here that does that. And I'm ready for questions. Yeah, okay.
Why was the string an array but the int is not?
Why is the string? Why the string is an array and the int is not? That's because of the string down here is string bracket 0. That is that's capture entry 0. All right. Anything else? Thank you.